Welcome back to the exercise application assignment. I'm your host, Grant Moon. Today we'll be talking. Let's see, it's Halloween at the time of recording this video. I was going to record the video yesterday, but I didn't really have my notes done. So here we are today. So basically, what I did yesterday for my training is it was legs, and I actually got to do the adductor machine, so I was pretty happy there. So I started off, I did my standing calf raises, and then I moved immediately into Smith machine squats. Didn't elevate my heel this time. I think my ankle mobility, my hip mobility is improving somewhat. So I didn't do it. It felt much more stable. It actually felt really good. So I did 4 sets Smith machine squats. Then I moved on to, my stiff-legged Romanian deadlift, which also felt pretty good. Not the greatest, but it was all right. The squats are always the hardest thing to get through. They're just brutal every time. It doesn't matter. You'll never get used to it. And then after that, I went into my dumbbell sissy squat, then my seated leg curls, and then what did I do after that? After that, I did the adductor machine. It felt pretty good. I forgot. Before I did the stiff-legged Romanian deadlifts, I did Meadows style Smith machine split squat, focusing on the glutes. My butt is very sore today. I will tell you that. My quads are decent. I know soreness isn't necessarily an indicator of muscular hypertrophy, but it's usually a indicator that, hey, you stimulated your muscles sufficiently. I don't know why. Something about, I don't know. My quads, man. I'm training them hard as hell. I don't feel like they're growing that much. It could just be an illusion, and it could just be my hamstrings and glutes need to be brought up, and then maybe it's kind of like how you might feel like your biceps are small, but really it's like if your triceps were bigger, they'd look better in proportion. It could be a situation like that. Well, let's talk about how that applies to training. How that applies to lecture. In lecture, we covered, the basics of endurance training responses, which is, not something I do. But in my notes, I found out that resistance training has this sort of, what's it called, a transcriptor? It's called something like a transcription activator called MTOR, which is going to be your signaling for contractile protein synthesis. But if we're talking about endurance training, which I don't do a lot of, but let's say, hey, my cardio conditioning class where we're doing a lot of, aerobic based exercises, surely it's endurance training to some extent. What you're going to have is an adaptation locally, whatever muscles that you're working. It's important to remember that it is local, and the adaptations you experience are specific to that muscle, the muscle groups that you're training. What you're going to have is mitochondrial biogenesis, and you're going to have increased capillary density, and you're going to favor more lipolytic processes for energy. There's a lot that goes into that. I don't know exactly what I should go into right here. Like, would be the best thing to converse about. Maybe we could talk about the primary. Let's speak about primary messengers, and then I can talk about other stuff when I get there. But if we're talking about, I want to make sure I have this. Yeah, so all I'm trying to do is increase my VO2 max with that sort of training. But you have your primary, damn, where is it? Took a lot of notes. Your primary signals. So your primary signals during endurance training are going to be calcium, your AMP to ATP ratio, your free radicals, and what those are going to do is essentially stimulate your secondary signals, which are, if it's calcium, you're going to stimulate calcineurin and CAMK. AMP ATP ratio is going to activate AMPK, which is an important one, and your free radicals are going to stimulate P38 and NFKB. CAMK, AMPK, and P38 are going to activate PGC1 alpha, which is the main thing that governs mitochondrial biogenesis, and it's also going to encourage that fast to slow shift in the synthesis of antioxidant enzymes. Antioxidant enzymes are going to be important for slowing fatigue. When you slow fatigue, there's going to be an afferent signal sent back to your cardiorespiratory control centers that's going to essentially lower the amount that your heart has to respond to, what's going on. So your local factor, you're going to have a less production of local factors. So your group 3 and group 4 fibers are going to respond to your spinal cord and then to your cardiorespiratory centers, and you're going to have like a less, that's not a less response, a reduced response in terms of hiking up your heart rate and your ventilation.